Hey guys, this is my project Basic Hand Gesture Recognition, and we use convexity defects to detect hand gestures. So in this project I wanted to use classical image processing methods to detect the gestures from the hand. And so in this project what we do is the steps that we use to detect the hand gestures is first we receive the real-time images from the JavaScript that's inside this Pluto notebook. Then we define a region of interest in the image and get that particular part of the image and feed it to our object tracker and then to our convexity defect tracker. So then what we do is convert that our region of interest image to HSV space and threshold it to detect skin. And after that we receive a binary mask and we apply map window and dilation on that particular mask to remove the small blobs and noise. And after that what we do is we find the contours from that particular mask using the Suzuki ABA algorithm, and after that we identify the convex hull of the binary mask to find uh, to find the convex hull points. So what are contours? Contours are basically like the boundary of object in the image or multiple objects. In this we wanted to restrict ourselves to the mask of hand basically, and the convex hull points are the points that are basically like the boundary end points of the basically some points that cover the mask completely. I'll explain the difference between the convex hull and contours later. Then what we do is we use the contour points and convex hull to find the convexity defects, and convexity defects wasn't really available in Julia, so I had to write my own in that my own version of it. And yeah, I'll be explaining it slightly later now. And after we find the location of the convexity defects, we plot the points and the number detected in the image, and this happens every 100 milliseconds. Okay, let's now discuss about contours, convexal, and the convexity defects. So as you can see this image, we get the outer boundary of the hand is the contours of from the image that we get, and the boundary that covers that whole hand, not these small boundaries, but the whole hand mask kind of, is the convexal. And the defects are the ones that these kind of grooves in the image in the contours are the convexity defects that we intend to find in this project to use for our gesture recognition part. So what we do is we have to define these regions. So like for convex hull there are like several points of the convex hull, this one, this one, this one, this. So these are like the, how many regions do we have? 1 2 3 4 5 6. We have 6 regions, and corresponding to them we have the contours for those regions. What we want to do to find these convexity defects is define we go region by region of the convex hull point pairs, and what we do is form a line from this point and this point, let's say, and all those we find the distance of that line, contour pair line, uh, or to all the contour points. So like there will be like over 100, let's, that won't be like a number we can define here, but let's say we have 100 points here. So what we do is find the normal distance of these points to this line, and we pick the most distant point. So in this picture, D1 and D3 are smaller than D2, and so are the several other points. So this is like the max distance point. This will be our convexity defect, and we will be returning C2 for this region. And similarly for all the regions we will have these convexity defects. Yeah, so we will have several convexity defects. Now there will be several cases that I want to ignore. there will be several edge cases that I wanted to address. So there are several keywords. I would like to talk about them. So for contour points, I use the Suzuki Abe algorithm, and to find the convex hull, I use the standard implementation from image-morphology.jl. And other than that, to match these contour points and these regions, I had to define several keyword arguments that enhance the performance. So those can be used to set the distance of edge cases and so and so. And next thing we have is the min dist. So we can also set the minimum distance of the convexity defect from the line. So just in case there is suppose there is a very small region and the convexity defect is too close to this particular line and we want to ignore it basically. So what we can do is increase this min distance parameter. And the next argument we have is the cure size, which is basically a method to also eradicate smaller regions. So suppose there are like in a region there are less than 50 contour points, we will be ignoring those regions. Next we have is D1, D2. So suppose there will be several points which will so suppose let's say we have D1 and D2, and let's we want and the distance of C2 from H0 and C2 from H1 is D1 and D2 respectively. We can set the minimum distance from both the points, and increase and decrease based upon our needs. There will also be cases where we want to ignore the cases of obtuse angle convex defects. So there will be, like in this particular image, there are two convex angle convexity defects, this one and this one. And if we want to ignore that, what we can do is set the max angle that we want in our convexity defect. So the angle that we are talking about is this angle from H0 to C2 and H1 to C2. So this particular angle. So we want to ensure that this angle is not more than 90 degrees as a default argument. I wanted to explain the details rather than exploring this live demonstration, which I'll be adding a video later. And so what we do is get the image from the JavaScript, which provides us a raw camera data. Then we apply our object tracker on it, which calculates the convexity defects and returns back this image that we have here. And what we do after that is convert the image to Cairo surface to draw on it, and basically draw the number, our prediction, on top of it and return it as a matrix. Now let's see the live demonstration that we have. In the background I have a green screen to ensure that the color of the skin is very distinct, because it's nighttime, so it's difficult to differentiate the colors. Maybe it works better in the daytime, I have noticed that. So but for the time being I'm using a green screen to ensure that the colors are very distinct. So here we have a hand, and yeah, let's start with a 5, 4, 3, 2, and one could be this or this, depending on the use case. We have to define a scenario for 0. Yeah, this is it for now. As you can see, those blue dots in the image are the convex defects, and that's what we are using for our calculations, and they work reasonably well for a very simple system using the classical methods. Yeah, let's move the hand a little bit back. Okay, that's about it for this video, guys. In the next video that will be coming on the same project, we'll be doing the same thing in the makey.jl with using videoi.jl. which will be more robust and faster than this, and will be applicable on a much larger image. And yeah, that's worth exploring. And after that, we'll be exploring media pipe, which also which is a trained model, which provides trained model for hand gest and landmark recognition, and basically palm detection. And then most probably we might be moving on to developing our own hand recognition system using units. It's all going to be exciting. Bye bye, I guess, for now. Tada.